Hello again, welcome back to the sailboat building project video series, whatever this may be. If you're new to the channel, my name is Panu and I'm just about to start building this 15-meter liveaboard cruising sailboat. There's already a few videos of what kind of boat this will be, so I suggest you check the plan videos up there somewhere. The project status is that I'm currently doing the plans for the boat with American designer Marie Tanton, and to be able to build it here in Finland I really need some kind of workshop, and that's what we are doing right here. So I'm hoping in next few months we will get the shed up and running, and then we can start building the actual boat. I have also built this really big CNC machine, which is going to be essential tool for this project. I'm 3D modeling the whole boat and I'm really trying to manufacture the parts instead of kind of cutting and figuring everything out by hand. And if you like to follow these kind of projects, I suggest you subscribe the channel right now and give me a thumbs up. It's really starting to help me with this project, so the more subscribers and more little revenue I can invest in the cameras and microphones and stuff. The goal, of course, is to document this build project as best as I can and have a really professional camera gear inside this workshop, so looking really forward to that as well. And if sailboats are in your heart, and I know many of you do, please consider going into the Patreon page and support the channel and the project that way as well. And another thing you can support this project is to purchase t-shirts and hoodies. The link is down in the description. They are very good quality, eco-friendly, 100% cotton shirts, and I really like them, and I hope you like them too. We're just about to start the groundwork here at the site. Without further yammering, let's go and do it. Okay, the first batch is now done. It's the driveway to the shed, and now we're waiting for the next one to continue with the actual shed foundation. We're just putting gravel under the shed and leveling it down, and that's basically it. And here we go. There has been a couple of days of work to get this groundwork done, and now it is mostly complete. Let's check it out. So there's now a few loads of gravel leveled down on this plot. The first batch we did ourselves with the tractor last week, and today there was this amazing excavator guy to level this down. So now it is mostly complete. There's quite a bit more than I anticipated of this gravel, because the corner back there was a bit higher than we thought, and I wanted to get a good layer back there as well. So there's maybe half a meter of gravel on this end. But now it's all done, and now I'm just waiting for the insulation to arrive in a couple of days. Then we can start laying that down. I still might go through this surface with that machine that like a does something like this. I don't know the name of the machine, but yeah, basically lays down the gravel even more and makes it more stable. On top of this, we're going to put 10 centimeters of insulation and then concrete floor. And the purpose of this gravel is to balance the weight of things we're putting here, to keep them stable, but also to prevent moisture from rising from the ground to that concrete floor. So that's why this is quite a loose material and it has no small sand in it. Mostly my time has now gone waiting for things, but I think we're getting through this project very soon. So the next job, of course, we are waiting for those insulation boards to arrive, and then we start to make molds for the concrete foundation, and that's maybe the biggest thing we are going to do here. They are quite big actually, going all the way around of this area. So nothing that special about this project, but it has to be done in order to get to work with the boat project. Now when I'm here, this is actually surprisingly small. The boat should fit on this end, and on that end there will be some tools and maybe some other things. I have to figure out the layout of this interior a little more in detail. Quite soon actually. The weather has been a bit of a challenge. It has been raining quite a lot lately. Fortunately, this week looks quite good, although I'm not sure if I can make it here very often. I have to do some work to get the money to build all this. I think we'll leave this place for now and let's go check some other plants or things. Just a quick visit to the CNC machine. I'm here just to pick up some supplies for the shed build, but at the same time I figured out I could test fit this sewer pipe thingy to this router. So the idea here is to use it as a dust collection. This is 75mm hose and this router is 80mm, so it doesn't fit exactly there. But I figured out if I split this and put the clamp here, it should fit on that spindle, and then I can put the vacuum hose in here and it should suck all the dust and stuff through this pipe. So let's try to do that. Okay, here we go. It fits there. It's not perfect, all right, but it feels quite okay. It could go a little deeper. This edge right here is the maximum depth I can really fit it. So it goes right about here. And as you can see, it's a little deeper than the collar. Okay, now it's split in half. Now it should go there all the way. Yeah. But now the gap here is quite big. I think it's better now, all right, but it's not perfect. It would have been so good if it would have fit perfectly. Maybe if I use a little longer router bits, it would work like this very well. There's a bit of a gap here, but I don't think that matters anything. Okay, I shortened it a bit. Now it's just about the right length, a bit long maybe. And I found one clamp lurking down on the shelf, and now it's firmly there. Let's try it out. So I have just this regular shop vacuum here. Now this is too big for this small hose. On my workshop I will have a little bigger hose to fit in there, of course. Okay, bit of paper towel will do the trick. Let's put this thing on. Sorry about the noise. Okay, the suction wasn't enough to pick up this small dust debris when the spindle was off, but I try to screw this down and then we can take a few test cuts and see how this performs. Alright, now there's this scrap piece here. Now I put the vacuum on and we'll do some cutting on that piece and let's see how that dust shoe performs. Alright, it somehow works, but it's not perfect at all. Quite a bit of stuff flying around. I think the smallest dust did go up there. And of course I don't have the feeds and speeds all figured out yet. But I think it's better than nothing. I think I will start with this. And maybe I should add some things going around that pipe so it won't push all the particles off that area. But as I mentioned, this vacuum is not nearly as powerful as it should be. But yeah, I think I will go with this one. Alright, this was a nice little addition to this video. Simple project, very cheap to do, nothing really special about it. Of course, everything can be better every time, but I will start with this thing. So, why do I need a workshop in the first place? Let's start with Finland's location on this globe. I mean this globe. Finland is located here, quite north. Actually, Helsinki is the second northernmost capital in the world. Only Reykjavik in Iceland is more north, but those people are just crazy living there. If we compare this location to Canada, for example, you can see that the same latitude, there's really nothing more than tundra and polar bears and stuff like that. So we are quite north indeed. The city of Lahti, where I live, is about 100 kilometers north from Helsinki, which is basically the same. However, Finland belongs to the borealis forest zone of the northern hemisphere, and the reason for that is the Gulf Stream, which you can see here. The Gulf Stream brings Caribbean heat from the equator to the northern Atlantic, and from there is constant flow of low pressures that go northeast direction and brings heat and rain to the Nordic countries. Fortunately, Norway with its mountains takes up most of the rain, so the conditions in Finland are quite okay and humane. Sometimes there is airflow from the north and then it can be really cold in here. So here in the north the summers are light and warm and sun is shining almost around the clock. On the other hand, winters are cold and dark. Autumns are just nasty and springs are, well, a little less nasty. But summer is nice. And winter. All that means that the average temperature here is less than 5 degrees all the year round. In summers it may be just above 15 degrees and in winters it's well below zero. When it comes to boat building, temperature when working with epoxies and other adhesives should be, well, above 15 degrees. That means that in here those conditions exist maybe 3 months in a year, and that time is the summer, when it would be nice to spend some time outside and go for sailing, for example. All other seasons we spend time inside, except in winters we go snowboarding or skiing or something like that occasionally. And sauna is of course used all year round. In order to create suitable conditions for boat building in this part of the globe, an insulated and heated workshop is essential to be able to raise the temperature above that 15 degrees when needed. Except for the coldest day of the winter, it might be not worth to try to raise the temperature anyway. It can be like minus 25 to 30. One benefit of making boat in here in insulated workshop is that when we heat up air, it dries quite a lot. So at winter time the air inside can be very dry, and that means that also the timber and everything else will be very dry, and that's obviously a benefit. All right. I spent a lot of time pondering what kind of workshop should I build. There were two main requirements. It had to be cheap and it had to be easily dismantled. The plan is to sell this workshop after this project is done, so that I can get some money to buy equipment for the boat. It can be sold as is, or it can be dismantled and relocated. The first idea was to build a pile of insulated wall and roof elements, which then could be assembled on site. Another option was a pillar beam structured wooden frame with industrial insulated panels on top. In these both cases, the sizes of the structure became a problem. The workshop is reasonably high, and here, in addition to wind and rain, snow loads must be taken into consideration. With these plans, the price of the frame that can handle the snow loads and the wind loads just went too high. My structural engineer friend then suggested that I should go and take a look of ready-to-go fabric halls that don't hold snow on them and make separate layer of insulation inside that tent. This would separate the weather protection and the heat insulation, and the solution would be quite affordable. So in early summer, before I even had this plot, I ordered this 225 square meter fabric hall, which is about right size for this project. The hall is 18 meters long and 12 meters wide and about 7 meters to the highest point. The 50-meter boat fits nicely in the hall and leaves additional space for all the tools and equipment I need. I haven't done the final arrangement yet, but there will be at least some kind of clean office space, a composting toilet, and probably a separate space for the dust collection machinery, just to control the noise and dust a little bit more easily. We will return these later. The hall has steel frames which are bolted to the concrete foundations, and the outer surface is made of PVC fabric, which is UV resistant and reasonably long lasting. Fabric is slippery enough so that snow should come down by itself. Of course, this needs to be observed closely because the frames are not designed to hold the weight of the snow. So I of course made a 3D model of this thing and designed small foundations for it, which you can see here. The foundations keep the whole place and in shape, and also there will be concrete floor which is connected to the foundations as well. So there will be plenty of mass to hold the whole thing in place. This fabric therefore acts as a shelter against wind and rain, but protection against temperatures is still needed. The plan here is to build a separate wooden frame, which you can probably see here, inside of that hall, and then put 100 millimeters insulation inside of that. So that's the complete structure of walls and roof, like that. And this is the final shape of the inside of the workshop. This inside then can be heated if necessary above 15 degrees, as I mentioned before, and the plan is not to keep the hall warm all the time, just when it's needed. The heat source itself will be air heat pump. But the workshop not only has to be insulated from the outside, but also against the ground. The same 10 centimeter insulation is put here against the soil, and it has three purposes. First, it of course prevents heat from going from the workshop to the ground, and therefore keeps the floor reasonably warm. Second, the insulation prevents moisture evaporating from the ground to the inside of the hall, so it keeps the hall dry. And third, it prevents the heat from the ground evaporating to the air. So in Finland, the big issue with buildings is that the ground freezes in winter time, so it is necessary to insulate the ground so that the heat on the ground stays down there, so it cannot be frozen. The problem is, as we know, when water freezes, it expands, and therefore it can move whole buildings and their foundations. So in this case, I probably won't be completely preventing the freezing of the ground, but most likely it will be very minimal. Underneath the insulation is the layer of gravel or rubble, as we saw earlier. The function of that is to distribute the weight of all this against the ground and also prevent capillary rays of water from the ground to that floor. So this shelter is protection against wind, rain and extreme Arctic temperatures, and now its construction has begun, and let's go back there and take a look how that goes. Alright, and now the real work begins. Last night I brought this pile of wood here on the site, and now the plan is to make the molds for the concrete foundation. So let's get to work.